which is used in this complex numbers, and it is called de Moivre's theorem. Now this de Moivre's theorem say that if I take the nth power of this complex number, okay, if I take the nth power of this complex number, the argument will get multiplied with n. Okay, this thing we have already studied, but we'll study it in the polar form now. Okay, so this will become cos n theta plus iota sin n theta. So if I take a power n of any complex number, okay, the arguments will get multiplied with that particular n. Okay, this can easily be proved with Euler form, because if I take the n power of this complex number, this is equal to iota n theta. Okay, so the argument of the resulting complex number will be n theta, right? So let's do a question on this application. Question is, find the argument of this complex number 1 plus cos theta plus iota sin theta to the power 5 divided by cos theta plus iota sin theta to the power 3. So in this case, I have to find the argument of this complex number. Okay, we'll start it by doing a simple trigonometric application. This can be written as 2 cos square theta by 2 plus 2 iota sin theta by 2 cos theta by 2 to the power 5 divided by cos theta plus iota sin theta to the power 3. Now we get 1 cos theta common from here and 2 common from here, so we'll get 2 cos theta by 2 to the power 5. In the bracket we'll get cos theta plus iota sin theta to the power 5 divided by cos theta plus iota sin theta to the power 3. Now we can easily apply this de Moivre's theorem over here. If I have a complex number and I'm multiplying it 5 times, I have a power of 5 on this complex number. So what will happen to the argument? That argument will be multiplied by the factor of 5. And similarly, in the denominator, this argument will get multiplied with the factor of 3. Okay, so this complex number will become cos theta by 2 to the power 5. The complex number will be cos 5 theta by 2 plus iota sin 5 theta by 2. Similarly, the denominator will become cos 3 theta plus iota sin 3 theta. Okay, so instead of multiplying this complex number 5 times, I easily draw this conclusion using the de Moivre's theorem. I just simply multiply this argument 5 times, okay, and this argument with a factor of 3 instead of multiplying it 5 times or 3 times. So the resulting argument of this complex number, as we discussed right now, the property argument of z1 upon z2 is equal to argument of z1 minus argument of z2, and the argument of the numerator is equal to 5 theta by 2 and the argument of denominator is equal to 3 theta. Therefore the resulting argument will be equal to, the resulting modulus is equal to the power 5, and the resulting argument will be equal to 5 theta by 2 minus 3 theta plus iota sin 5 theta by 2 minus 3 theta. Therefore this will become 2 cos to the power 5 theta by 2 cos minus theta by 2 plus iota sin minus theta by 2.